Hello. In this video, we're going to go over how to properly use the variable blocks in Robot C. To get started, we're going to click on Open File and make sure you open up the template file that has been provided in this assignment. If not, please download it off of Canvas so you have it for later use. This file has all the motors and sensors in their proper ports that align with the robot that we are using in class. So just to refresh, we have the three different types of variable inputs. In order to use a variable, we have to first establish a value for that variable and a name. So the three methods for defining a variable is with a constant number, which you can just type in any number, positive or negative. You can select a value basically from any kind of sensor data or a timer or any other variable. So we can use a timer and count it in seconds. Or we can use an equation. So same thing as before, we can bring in some kind of value and then we can modify it by using addition, subtraction, multiplication, or division. So to get started with defining the variable from the drop-down menu, you might already have a variable already defined. If not, you can edit a variable that you've already defined, or you can add a variable. So to get started, all you have to do is type in a new variable. I'm going to call it variable 1. So here we've set variable 1 equal to 125. We can create a second variable, just call it variable 2. And now variable 2 is going to be equal to the timer whenever it's read. So if you have, once the program started, that timer is going to start from 0 and just count up, and whenever the variable shows up in the program, that's the time it's going to read, and then move on. For the third variable, we can just call variable 3. And again, we can pick some kind of value, so we can take the light sensor and we can multiply it by 10. So each of these give us a different value. Using the equation one, we can take a sensor data and then convert it to some usable data that would be easier for us to make decisions with. The sonar converts to inches for us, but all of the other sensors give us raw data, so we have to determine through experimentation what values for the sensors equal something meaningful for us. So if there's a threshold for the light sensor, we can define that as, we can define it on a scale of 1 to 10 on light intensity. So you take the entire scale of the light sensor, which you'd have to test, complete darkness and then maximum light brightness. And then you could divide that or multiply that by whatever scale value you would need to create whatever scale you want to create. For the potentiometer, it goes 0 to 180 degrees, but it reads 0 to about 4200. So to convert that, actually we can go ahead and do that one. To convert 4200 to 180 degrees, you just grab your calculator. 4200 divided by 180 is equal to 23.3. So now we can divide that value by 23, and now we can actually add a variable, create a new name, and call it arm angle. We cannot have spaces. So you can use capitals to kind of have multiple words together as a variable. You cannot have a space in your variable name. So this equation here, we take the arm angle, which is our variable, and we get it from taking the raw sensor value from the potentiometer and dividing it by 23. This will give us the angle of the arm in degrees. So we know how to set up the variables using the three different types depending on what we're aiming for. Now, we use them in place of sensor data for our program flow. So if we have an if statement, a while loop, a repeat loop, we can use these variables instead of sensor data. So for instance, for while, we can take our variable, take variable 2 because that has the timer. While variable 2 is less than 10 seconds, or less than 10, it's going to stay in this loop. So what this is going to do is each time it loops, this variable 2 value is going to be updated by the timer, and it's going to stay in here until it counts to 10 essentially. Just to be safe, if you go down to timing, we can add a reset timer above, and T1 matches up with the T1 here. So when the program starts, we're sure that we cleared our timer back to 0, so it will start counting from 0. For variable 1, this would just be something that you'd want to store a scalar value. If you have like an if statement, we can kind of use them as codes. So let's say we have our distance sensor. If our distance sensor is less than 10 inches, we can have our variable 1 set to 10, and then we can take that again. We can select variable 1 again. If it's greater than 10 inches, we can set it to 20. So this would be an if statement where we can change that variable in a fixed amount depending on some kind of sensor data. For arm angle, so if we want to have the motor raise up the arm, so while arm angle is equal to arm angle while arm angle is less than, so let's say we want to have the arm raise up 90 degrees. We can copy this. You hit Control C to make a copy, or you can right click, copy, and then you can right click, paste. So what this does is we set up the arm angle variable. By default, it'll start at 0, but we're just initializing it in case outside the loop it happens to already be above 90, then it wouldn't do this. But what this is going to do is if the arm angle, the variable that we've created, is less than 90 degrees, we can take our set motor, find our arm motor, and we can set it to 50. So this will move up. And then when it exits, we'll stop all motors. So what this is going to do, this entire program, is we're going to reset our timer to 0. While our variable 2, which is set to be equal to our timing value, is less than 10, we're going to keep looping. So essentially this is going to loop for 10 seconds. After that, we'll move on to our if statement. It's going to read our sonar value. If it's less than 10, it's going to set variable 1 equal to 10. If it's greater than 10, it's going to set variable 1 equal to 20. So that's just a binary choice where you can, if you have error codes or something where you want to hide them, you can, when it's running, you can see the display of your variables in real time. So you can kind of keep an eye and know where in the program it is. So for kind of monitoring the flow of the program while it's running. After it does that, it checks the sensor value for our potentiometer. It divides it by 23, and then we get our arm angle converted from the raw sensor data into the angle in degrees. So what this is going to do is while this arm angle is less than 90, so assuming our arm starts from a bottomed out position, it's going to set our motor to lift our arm motor up until that arm angle gets above 90, in which case it'll exit the while loop and stop all motors. Variables are useful because what it does is these sensor data is constantly changing. So what you can do is at certain times you can save previous values or important values like minimum or maximum, and then replace them as they change or as new data is added. But you can basically store information to access later. That's the main point of a variable. It's not like an algebra where we're solving for them. They're more of like storage points that we can then reference later to compare other numbers to. So as long as you followed along, make sure you submit the code onto Canvas. Make sure you file, save as, save it as variables, and then upload to Canvas.